I'm Chris Anderson at the EU Web Tech Lab, and today we have IDT RF switches. The highlight of these switches is IDT's unique constant impedance technology, which they refer to as KZ. As the name implies, this technology keeps the impedance constant during switching transitions. This controlled impedance translates to greatly reduced VSWR, meaning no more transient spikes to destroy amplifiers and ADCs. It also means less RF polling on oscillators and less phase and amplitude variation on non-switched paths. All of this leads to improved system reliability and performance. We have a couple of eval boards here. One is for the F2915 5-port device, and another for the F2923 2-port switch, which we'll be using for the demo today. Since we have a lot of wires and cables going on here, let's just go over the setup really quick. So on the F2923 eval board, this of course is the IC itself. These two connectors over here are used for a through cal so that you can de-embed the effects of the board. This header block here is to set the different parameters for the F2923. As it is currently, we have it set up for 1-pin control. These two test leads are connected to CTL2, which allows us to switch between port 1 and port 2. They're connected back to our waveform generator, which is set to a 1 kilohertz, 3.3 volt peak-to-peak output. So we'll be toggling between those two ports at 1 kilohertz. We have our 3.3 volt DC connection, and then we have our port 1 and port 2 connected to our scope on channels 4 and 3 respectively. And then our RF common, which is connected through a directional coupler back to our waveform generator and our oscilloscope. And so we have a 120 megahertz input to the directional coupler, so that will feed through into the RF common, and then it will be output on either port 1 or port 2. And then the reflection of that will come back through and go to the oscilloscope as well so that we can measure that. So now I'll turn on our outputs. We'll turn on switching and we'll turn on our signal. And so you can see here the pink and blue traces are RF1 and RF2, so our two ports, and our input signal is getting switched between those two, and so you can see that transition. Actually, if we come and turn off the 120 megahertz signal, on the green trace what you can see there is the video leakage. And so depending on your application, you may filter that out, you may not, but that will affect some of the other parameters that you look at as well. So going back to that constant impedance feature of these switches, which is really the highlight, when you keep that impedance constant, then you don't get these big voltage transients. And one way to look at that is your voltage standing waveform ratio, or VSWR. And what I can't do with this scope live is de-embed all the effects of our setup here and remove video leakage to go and calculate that VSWR. Now, depending on your application, video leakage might be important. If you're narrowband, you'll probably filter it out. If you're wideband, it might matter to you. But what you would do then is you would download this data, and then you would apply this, this rolling calculation where you have this window that moves so that you can calculate your VSWR. So when I applied that calculation to my setup, what I ended up measuring on the output after the directional coupler, so my incident wave into the switch, was about 330 millivolts, and my reflected wave coming back out was about 25 millivolts or so. And so I ended up with a VSWR of about 1.17, I think it was, but well within range of what IDT claims on their data sheet, and well below anything else that I've ever measured here. And again, the lower you keep that, the less protection circuitry you need for your other components, which generally will improve performance, reliability, it'll reduce your solution size and so your solution cost. And so all of those things are very good, and that's why IDT has come and released this constant impedance switch. IDT's approach to RF delivers important innovations, with constant impedance switching benefiting designers with reduced switching time and lower VSWR while switching. For more information on IDT's family of KZ switches and other RF products, visit IDT.com.